Hello there. Today we're solving word problems with systems. I'm going to show you 3 examples of word problems that can be solved by systems. The first one is called an integer problem. 2 integers have a sum of 14 and a difference of 24. Find both integers. So since this is going to be a system of 2 equations and 2 variables, we're solving for 2 things, and that's the 2 integers. So since we don't know what they are, we're going to give them variables. I'm just going to call the 2 integers x and y. So first I'm going to translate the first part. 2 integers have a sum of 14. So the order of the integers doesn't matter. They have a sum of 14, so x plus y equals 14. And they also have a difference of 24. So x minus y equals 24. It doesn't matter which letter goes first because we don't know either of the integers yet. And now you see we have a very simple 2 by 2, 2 equation, 2 variable system. And I can choose whether to use substitution, elimination, or determinants. I'll do this one by elimination or linear combination. So I'll go ahead and add these 2 equations. Y is eliminated. I'll continue over here. X is 19. I plug 19 in here. 19 plus y equals 14, so y is negative 5. So the 2 integers are 19 and negative 5. Now just for kicks, I'll solve for x by determinants. 1, 1, 1, negative 1 goes in the bottom. 14, 24, 1, negative 1 goes in the top. And then I do my crisscross. Negative 14 minus 24 over negative 1 minus 1. Negative 38 over negative 2, that is 19, and which is what I should have gotten. Okay, the next problem is mixture problem number 1. I'm calling this a mixture problem because in this problem we have 2 items mixed together, but the 2 items have different characteristics. In this case, the 2 characteristics are the value of the 2 different stamps. We have 20-cent stamps and 25-cent stamps. So these 20-cent stamps and 25-cent stamps are mixed together to create a bunch of stamps that cost $7.75. Okay, so Jack buys some 20-cent stamps and 25-cent stamps for $7.75. If he bought 35 stamps in all, how much of each type of stamp did he buy? So since I don't know how many 20-cent stamps and how many 25-cent stamps he bought, I only know the total number of stamps. I'm going to call X the number of 20-cent stamps, and Y is going to be the number of 25-cent stamps. Now I know that each 20-cent stamp costs 20 cents, right? So 20 cents times X is going to be the amount of money that all those 20-cent stamps are worth that Jack has. And since each 25-cent stamp is worth 25 cents. 25 cents times y is going to be the value of all those stamps. If I add the value of all his 20-cent stamps together and the 25-cent stamps together, I get $7.75. That's basically what the problem is telling me. But I also know something else about these stamps. I know that he bought 35 in all. So that means this number plus this number is 35. So here we go, x plus y equals 35. Here is my 2 by 2 system. Now, in this case, well, first of all, I really don't like these decimals here. So I am going to multiply this first equation by 100 to move those decimal points away. So if I move the decimal points 2 to the right for everything, I get 20x plus 25y equals 775. Okay, I think what I'm going to do here is multiply I guess I'll multiply this equation by 20 and get 20x. So I'm going to put the result here. 20x plus 20y equals 20 times 35, which is 700. And then I'm going to eliminate x, so I'm going to subtract these two equations. 5y equals 75, continue over here. Y equals 15. So that means I have, since y stands for that, I have 15 25-cent stamps. I'm going to stick 15 in here for y. And I can do this part in my head. X plus 15 is 35, so x is 20. Okay, so I'll put the answer over here. I have 15 25-cent stamps and 20 20-cent stamps. Okay, and now we come to the third problem, which is mixture problem number 2. So again, we're going to have two types of things, and those two types happen to be quarters and nickels. Perry has 50 coins. Some are quarters, some are nickels. If he has $5.10 in total, how many does he have of each type of coin? Okay, we know that quarters are 25 cents. I'll put a little 25 here. And nickels are 5. So first, we'll get the value equation. So we have some coins that equal $5.10. We don't know how much, but we do know how much each quarter is worth. So 0.25 times the number of quarters plus 0.05 times the number of nickels. And we know that we have a total of 50 coins, so x plus y is 50. Okay, like before, I'm going to multiply this by 100. There we go. And this time I'll just do it by substitution, just for a little variety. So I'm going to take the first equation here, change it to y equals 50 minus x. and I'm going to put that in there. So this second equation becomes 25x plus 5 times 50 minus x equals 510. Distributing here. Continue here. Combining like terms, 20x, subtracting 250 from both sides as well. And dividing by 20, x equals 13. Here, I better write x is quarters, y is nickels, so I don't forget what's what. So 13 quarters, I'm going to put the 13 right here. 13 plus y is 50, so y is going to be 27. Or is it 37? It's 37. Okay, so my answer is 13 quarters and 37 nickels. Okay, so there we have it. Solving word problems with systems of two equations, two variables. Just to sum up, remember, read the whole problem carefully, set up your variables, make sure you're clear on what they stand for, then translate the first part, which gives you the first equation, translate the second part, which gives you the second equation. And we've done enough practice with solving that the part after that is all downhill from there. Okay, next time we'll still be solving word problems, but more complicated ones. See you next time.